Dear friends, in this session we will discuss two very interesting and useful features of C programming language named structure and union. So far we have been discussing the primitive data types and some of the derived data types and using them in C programs. In a larger program, sometimes it may be necessary to organize a group of data items of different data types referring to a single entity. However, we cannot use an array if we want to represent a collection of data items of different types using a single name. A structure helps to define such a data types in C. Each data item is a member or field of the structure. Structures are slightly different from the variable types you have been using till now. Structures are data types by themselves. When you define a structure or union, you are creating a custom data type. For example, a passenger who wants to reserve a railway ticket has to furnish the details like name, sex, age, train number, boarding place, destination, date of journey, etc. It will be convenient to handle all these details of a passenger as a single entity in a program. This information may be maintained for every passenger for further processing. Arrays can hold only data of similar data types and hence they cannot hold information having different data types. The need for structure arises in such situations. Structure declaration. A structure is a collection of one or more variables, possibly of different types, grouped together under a single name for convenient handling. Structures help to organize complicated data, particularly in large programs, because they permit a group of related variables to be treated as a unit instead of separate entities. Structures have declarations and definitions. The general format of a structure declaration is struct tag within braces declaration of member 1 semicolon, declaration of member 2 semicolon up to declaration of member n semicolon and close the brace and semicolon. The declaration begins with the keyword struct. The list of declarations of its members must be enclosed in braces. The tag is a name that identifies the structure. The individual members can be ordinary variables, pointers, arrays or other structures. The member names within a particular structure must be distinct from one another, though a member name can be same as the name of a variable defined outside the structure. For example, suppose we want to store data about a passenger which consists of passenger name a string, age an integer, train number an integer, boarding place a string and destination a string, so on. Let us see the structure declaration now. Struct passenger within braces char name 20 int age int train number char board place 20 char dstn 20, then close the brace and semicolon. The declaration uses passenger as a tag. Observe the semicolon after the closing brace. There are 5 members in this structure declaration. Tag name may be used as an ordinary variable name or a member variable name without any conflict in a program. After the declaration of a structure variable can be created as struct tag variable 1, variable 2 up to variable n. For example, struct passenger pass 1 comma pass 2 semicolon. This is the structure type variable declaration. This defines two structure variables pass 1 and pass 2 of struct data type. The structure definition reserve spaces for the structure variables. The members are stored in memory in the order they are declared in the structure declaration. There are different ways to define structure variables. The first one, struct tag within braces member declarations and close the brace semicolon. This is the structure definition. Struct tag variable 1, variable 2 up to variable n. This is the structure type variable declaration. In second type, struct tag within braces member declarations, close the brace semicolon, and type def struct tag new name semicolon. This is the renaming of the structure. New name variable 1, variable 2 up to variable n semicolon. This is the structure type variable declaration. In third type, type def struct tag, this is the structure definition with renaming within the braces member declarations and close the brace and new name semicolon. Then new name variable 1, variable 2 up to variable n semicolon. This is the structure type variable declaration. The fourth type, type def struct, this is the structure definition with the renaming braces, then member declarations, close the brace, new name semicolon, then new name variable 1, variable 2 up to variable n semicolon. This is the structure type variable declaration. In the fifth type, struct tag within the braces member declarations, this is the structure definition, then close the brace variable 1, variable 2 up to variable n semicolon. This is the structure type variable declaration. In the sixth type, struct within the braces member declarations, close the brace variable 1, variable 2 up to variable n semicolon. This is the structure type variable declaration. Observe the declarations and definitions carefully. There should be at least one blank space after the closing brace in the third and fourth methods. It is important to remember that only after the definitions the structure variables are created and storage space are reserved. The structure declaration should be terminated with a semicolon. Initializing structure elements. A structure element can be initialized in its definition itself with a list of initializers enclosed within the braces. Each initializer must be a constant expression and the order and type of each member must match the order and type of its declaration. For example, struct student within braces char name 20 int roll number float fees char division close the brace semicolon. Struct student S1 equal to within braces within inverted comma Arun comma 11 comma 3200 comma within single quotes A and close the brace semicolon. Struct student S2 equal to within brace within inverted comma Ram comma 27 comma 4000 comma within single quotes C and close the brace semicolon. A structure variable may be initialized by means of assigning another structure variable of similar type. For example, struct student S1 equal to S2 semicolon. This assigns the data of S1 to S2, but the structure variable at the right side of that assignment statement has to be defined and initialized or read before the assignment. The initialization method shown in the screen is also a valid one. Struct student within braces char name 20 int roll number float fees char division close the brace S1 equal to within braces within quotes Arun comma 11 comma 3200 comma within single quotes A close the brace and semicolon. Here the declaration and definition are combined. While declaring a structure, it is very important to remember that the member variables cannot be initialized. This is because a structure declaration does not reserve any memory space. Accessing structure elements. Having declared the structure types and the structure variables, let us see how the elements of the structure can be accessed. In arrays, we can access individual elements of an array using a subscript. Structures use a different scheme, they use a dot operator. So, to refer to name of the structure defined in our sample program, we have to use S1 dot name. Similarly, to refer to roll number, we would use S1 dot roll number. Please note that before the dot there must always be a structure variable, and after the dot there must always be a structure element. The corresponding C statements will be strcpy within bracket s1 dot name comma within quotes Ravi close the bracket semicolon and s1 dot roll number equal to 13 semicolon. How structure elements are stored? Whatever be the elements of a structure, they are always stored in continuous memory locations. Let me now illustrate the concept using a simple program. Memory map of structure elements. Hash include stdio.h. Main within braces, struct book within braces, char name 20, float price int pages close the brace and semicolon. Struct book b1 equal to within the braces within quotes book 1 comma 75.00 comma 225 close the brace semicolon. Printf address of name equal to percentage u ampersand sign b1 dot name. Printf address of price equal to percentage u ampersand sign b1 dot price. Printf address of pages equal to percentage u ampersand sign b1 dot pages close the brace. Here is the output of the program. Address of name equal to 64318, address of price equal to 64339, address of pages equal to 64344. Copying and comparing structure variable. We have already discussed that two variables of same structure type can be copied the same way as ordinary variables. If student 1 and student 2 belong to same structure, then the following statements are valid. Student 1 equal to student 2 semicolon, student 2 equal to student 1 semicolon. However, the statements such as student 1 equal to student 2 and student 1 not equal to student 2 are not permitted. C does not permit any logical operations of structure variables. In case we need to compare them, we may do so by comparing members individually. Nested structure. If a structure contains one or more structures as its members, it is known as nested structure. Let us consider an example that declares a nested structure to store date of birth of a student. We can declare a structure to store date as struct date within braces int dd int int yy close the brace semicolon. This structure date can be used as a member in another structure as shown in the screen. Struct student within braces char name 20 int roll number float fees struct date dob close the brace s semicolon. The structure date has been made as the member of structure student. To access the elements of the structure date, which is the part of another structure, we can use the statements like s dot dob dot dd, s dot dob dot s dot dob dot yy. Array of structures. A group of structures may be organized in an array resulting in an array of structures. Each element in the array is a structure. Let us now consider a problem where we need to store data of 100 students. Here we would be required to use 100 different structure variables from S1 to S100, which is definitely not very convenient. A better approach would be to use an array of structures. Let us now go through a program segment that shows how to use an array of structures. Struct student within braces int roll number float fees char division close the brace s 100. Here we define an array of 100 structures. Each structure variable S0, S1 up to S100 contains structure as its values. The members can be accessed as S0 dot roll number, S1 dot fees, like that, S100 dot roll number, S100 dot fees, etc. Now, let us see a program segment that reads and writes the above defined array of structure. Int I for I is equal to 0, I less than or equal to 99, semicolon I plus plus, within the brace, printf, enter roll number, fees and division, scanf, percentage %d, percentage %f, percentage %c, ampersand sign Si dot roll number, comma, ampersand sign Si dot fees, comma, ampersand sign Si dot division, and close the brace. For I is equal to 0, I less than or equal to 99, I plus plus, printf, percentage %d, percentage %f, percentage %c, Si dot roll number, comma, Si dot fees, comma, Si dot division. Pointer to structure. A pointer is helpful to create a structure dynamically. A group of structures may also be created dynamically using a pointer. A pointer to a structure is similar to a pointer to an ordinary variable. It is created in the same way that a pointer to an ordinary variable is created. For example, type def struct stud within the brace int register number char name 20 char result 10 and close the brace student semicolon. This declares a structure student. The definition student star sp semicolon. This creates a pointer variable sp which points to the structure student. After the creation of the pointer variable, it should be assigned with a suitable pointer value. For example, sp equal to within bracket student star malloc within bracket size of int plus 20 plus 10 close the brace semicolon. This assigns a pointer to a block of memory large enough to store an integer and 30 characters which are members of the structure. It is very tedious to calculate the size of the structure in this way if the members are more. The operator size of may be used to find the size of a structure as given below. Sp equal to within bracket student star malloc size of within bracket student close the bracket semicolon. Observe the cast operator to convert the generic pointer returned by the function malloc into a pointer to the structure student. After assigning the appropriate pointer value, the expressions star sp dot register number and star sp dot name may be used to access the first two members of the structure. An alternate notation is also provided in C for pointer to structure. The operator minus sign immediately followed by greater than sign can also be used to refer to a member. Now, star sp dot register number can be written as sp minus sign greater than sign and register number, and star sp dot name can be written as sp minus sign and greater than sign and name. Structure and function. A structure can also be used in functions. While using the same structure in different functions, it is essential to pass the structure as an argument. C supports the passing of structure values as arguments to functions. The structure variable or a pointer to the structure may be passed. In the first method, we pass each member of structure as an actual argument of the function call. The actual arguments are then treated independently like ordinary variables. This is the most elementary method and becomes unmanageable and inefficient when the structure size is large. When the structure variable is passed, the changes made in the members of the structure are available only in the called function, that is called by value. In the second method, we pass the pointer to the function. Here, we pass the copy of the entire structure to the called function. The function is working on a copy of the structure. Any changes to the structure members within the function are not reflected in the original structure, effect of passing by reference. Let us now consider an example for passing entire structure to the function. Passing entire structure to the function. Struct student within braces char name 20 int roll number float fees close the brace semicolon. Void display within bracket struct student s within braces printf name percentage s dot name printf roll number percentage d s dot roll number printf fees percentage f s dot fees close the brace. Hash include stdio dot h main within the brace struct student s equal to within the brace within the quotes Arun comma 12 comma 3500 close the brace semicolon display yes close the brace. Self referential structures. It is a structure which contains one member which is a pointer of its own type. For example, struct student within the brace char name 20 int roll number float fees struct student star next close the brace semicolon. Here the structure contains an element which is a pointer to a structure of the same type called next. Therefore, this is a self referential structure. Self referential structures are very useful in applications that involve linked data structures such as list and trees. Here the declaration, assignment of pointer value and accessing the data using the pointer must be done appropriately. Union. A union can be considered as a special type of structure. It is a derived data type that permits different types of data items in which each member shares the same block of memory. A union behaves as a storage buffer capable of holding different data types. In structure, each member has its own storage location, whereas all the members of a union use the same location. That is, even though the union may contain many members of different types, it can handle only one member at a time. Like structure, a union can be declared using the keyword union. For example, union mixed type, this is the union declaration within braces int a float b char c close the brace semicolon. Union mixed type empty semicolon, this is the union definition. This declares a variable empty of type union mixed type. The union contains 3 members, each with a different data type including empty.a, empty.b and empty.c. The variable empty will be large enough to hold the largest of the 3 data types. However, we can use only one of them at a time. This is due to the fact that only one location is allocated for a union variable irrespective of its size. Initialization of a union variable is restricted so that the value of its first member can only be initialized. For example, union mixed type within braces int a float b close the brace mix is equal to 5 semicolon. This is the initialization. Here the value 5 would be stored in the member mix.a. Unions are often used as members of structures and structures are used as members of unions. An array of unions, a pointer to a union, functions using a union are also possible in C. Also, a nested union and a self referential union can be used. The notation for accessing a member of a union is identical to that of a structure. Let us summarize what we have discussed in this session. A structure is a derived data type used to organize a group of related data items having different data types. The syntax of the structure declaration differs from that of a structure definition. The declaration informs the compiler about the prototype of the structure, whereas the definitions creates the structure variable. The declaration alone does not reserve space, whereas the definitions allocate space for storing the members. The members of the structure are accessed by the structure member operator denoted by a dot. A nested structure allows another structure as its member. An array of structures is used to organize a group of structures. A pointer to a structure is helpful in the creation and manipulation of a structure or a group of structures. To access a member using a pointer to structure, the operator minus sign followed by greater than sign is used. A self-referential structure is possible by having a member of a structure as a pointer to itself. A union is similar to a structure, except that only one member may be stored at a time in a union variable. Certain programs may be written using unions to conserve memory. Please try to solve these assignments. What are structures? Differentiate a structure from an array. Explain how structures are defined in C and how they are passed to functions. What do a nested structure and an array of structures mean? Differentiate between a structure and a union with respect to allocation of memory by the compiler. Give suitable examples. Write a C program using a structure to print the mark list for a class of 30 students studying 5 different subjects using separate function for input and output. Here are some books for your reference. B.W. Kennigan and D.M. Ritchie, The C Programming Language, 2nd edition, Prentice Hall, 1988. Yashwant Kanedkar, Let Us See, 10th edition, BPB Publications, New Delhi, 2010. Greg M. Perry, Absolute Beginner's Guide to C, 2nd edition, SAMS Publishing, 1994. Hope now you are fascinated with the C language and interested in writing C programs. Wish you all good luck. Bye.